All right, you are welcome again. Today, let's talk about the equations of a straight line. The equations of a straight line. We say that straight lines play important part in any geometric analysis. And we will consider its special forms. Equation of straight lines has special forms. We have slope-intercept form, we have slope-point form, we have two-point form, and we have intercept form, and we have perpendicular form, or we call it the normal form. So these special forms of equation of a straight line: slope-intercept form, slope-point form, two-point form, intercept form, perpendicular form. So we are going to take them one after the other. Okay, now let's go from the first one. We have slope-intercept form. How to find the equation of a straight line in the form of slope-intercept form. So we're going to have the formula that the equation of a straight line in slope-intercept form is going to give us y is equal to mx plus c. The equation of a straight line in slope-intercept form is going to give us y is equal to mx plus c, where m is called the gradient or the slope, and then c is the intercept. Okay, now let's go. Let's take some few examples. We have write down the equation of a straight line having the gradient 2 and y-intercept minus 5. Okay, you say write down the equation of a straight line having gradient 2 and y-intercept minus 5. Okay, so let's go. Solution: we have the equation of a straight line in slope-intercept form. That is based on the information given to you. You'll be given slope and you'll be given intercept. Okay, so to form the equation of a straight line. So now here we have y is equal to mx plus c. So where gradient is m and the intercept is c. So based on this information given to us, m is given to us and then c is given to us. So m is equal to 2, which is the gradient, and y-intercept is minus 5, which is c. All right, so in the equation of a straight line, we have y is equal to mx plus c. So when we fix it here, we're going to say that y is equal to m is 2. We have 2x, and then we have c is equal to minus 5. We have minus 5. So the equation of the straight line having the gradient 2 and the y-intercept minus 5 is giving us y is equal to 2x minus 5. All right? Yes. Example 2. Find the slope and y-intercept of the line 8x plus 5y equal to 20. Okay? Find the slope and y-intercept of the line 8x plus 5y equal to 20. So solution: you know that the equation of a straight line in slope-intercept form is giving us y is equal to mx plus c. So here we have the equation of the line 8x plus 5y equal to 20. So here let's try and make y the subject so that it will look exactly the same with this equation of a straight line. Okay, so now let's go. That means we have 8x plus 5y equal to 20. So let's take 8x to the other side. That means we're going to have 5y is equal to minus 8x plus 20. Okay, yes, we are interested in making y the subject. So let's divide through by 5. So we're going to have 5y divided by 5 all over minus 8x divided by 5 plus 20 divided by 5. So here we're going to have y is equal to minus 8 all over 5x plus, when you say 20 divided by 5, is going to give us 4. So the equation of the line is y is equal to minus 8 all over 5x plus 4. So here, comparing this with our original equation of a straight line, which is y is equal to mx plus c. So here we're going to see that our m, which is the gradient, is minus 8 all over 5. and then the y-intercept, which is c, is equal to 4. But the question says find the slope and the y-intercept. Now then we know that the gradient and slope is the same. So here we say that m, which is the slope, is equal to minus 8 all over 5. And then the y-intercept is equal to c, which is equal to 4. All right? Yes. Now let's go. Let's take another special form of the equation of a straight line. So another form is slope point form. So this is based on the information given to us. In the first one, we say slope intercept form. That is, slope will be given to us, intercept will be given to us. But this one here now says slope point form. That means a slope will be given and then a point will be given to find the equation of the straight line. Okay, now let's go. The formula we are going to use for this slope point form is y minus y1 is equal to m open bracket x minus x1. Hello. The equation we are going to use is, or the formula we are going to use is this. We are going to say y minus y1 is equal to m open bracket x minus x1. Okay, now let's take a look at this question. You say write down the equation of a straight line having gradient 4 which passes through the origin. Hello, which passes through the what? The origin. So we see that in this question, the slope is given to us, which is the gradient, and then a point is given to us that it passes through a point. Which point? Through the origin, and then origin is a point. So which point is the origin? Here we're going to have our point to be x1 and then y1. Okay, so the point origin is 0, 0. All right, and then we have the gradient, which is m, to be what? 4. Then the point, one point that's given to us, s, y is equal to what? 0, 0, which implies that it passes through the origin. At origin, we have x to be what? 0 and y to be 0. Now let's go. Applying our formula, we have y minus y1 is equal to m open bracket x minus x1. So here we have y minus our y1 is 0. We have minus 0 is equal to our m is 4 open bracket x minus x1. x1 is 0. So we have x minus 0. Here we're going to have y minus 0 is y equal to x minus 0 is what? X. X times 4 is equal to 4x. So here we have y is equal to 4x. So the equation of the straight line, which has a slope 4 that passes through the origin, is giving us y is equal to 4x. All right? Yes, let's take another example. Write down the equation of a straight line which passes through, number 1, 5, 11 and parallel to x-axis. Number 2, the point 0, 2 and parallel to the line y plus 8x equal to 0. Then number 3, 0, minus 1 and perpendicular to the line 3x minus 2y plus 5 equal to 0. Okay, yes. Now let's go. Solution. We have the point x1, y1 to be 5, 11. So 5 is our x1 and then 11 is our x2. Okay, we say that the point, it is parallel to x-axis. When it is parallel, that means that theta is equal to 0. So and then we know that tan theta is equal to m. Hello, tan theta is equal to what? M. So here that means that m, which is the slope, is equal to 0. Why? Because it is parallel. When it is parallel, that means theta is equal to what? 0. All right, let's go. Using our formula, we say that y minus y1 is equal to m open bracket x minus x1. So our y1 is equal to 11. So here we're going to have y minus 11 is equal to our m is equal to 0. So we have 0 open bracket x minus x1. Our x1 is 5. So we have x minus 5. So 0 multiplied by all this in the bracket is equal to 0. So here we have y minus 11 is equal to 0. Let's take 11 to the other side. So we have y is equal to 11. So the equation of the straight line which passes through the point 5, 11 and is parallel to x-axis is giving us y is equal to 11. All right, let's take the second one. You say we should find the equation of the straight line which passes through the point 0, 2 and then is parallel to the line y plus 8x equal to 0. Now we say that since the two lines are parallel, that means they have the same gradient. Two lines are parallel, that means they have the same gradient. Here we say that we have a line already, and then the line we're having already is y plus 8x. Okay, that is the equation of a line. We're having y plus 8x equal to 0. That is the line we're having already. Okay, so that means we have y is equal to minus 8x. So the m, or the gradient of this line, is equal to minus 8. So and then the equation of the straight line we are going to find, so is parallel to this line. Is parallel to this line. So and then if you say that two lines are parallel, that means they have the same gradient. Okay, so that means our m is going to give us minus 8. Then we already have a point. Okay, so applying our formula, we have y minus y1 is equal to m open bracket x minus x1 close the bracket. Now here we have y1 to be what? 2, and then x1 to be 0. So here we have y minus 2 equal to our gradient, which is m, is minus 8 open bracket x minus 0. Okay, let's simplify the bracket. When you say x minus 0 is x, so x multiplied by minus 8 is minus 8x. So here we have y minus 2 is equal to minus 8x. Let's take minus 2 to the other side. So here we have y is equal to minus 8x plus 2. All right, yes. So the equation of the straight line which passes through the point 0, 2 and is parallel to the line y plus 8x equal to 0. The equation of the straight line is giving us y is equal to minus 8x plus 2. All right, yes. Let's solve the last one here. Number 3. We are to find the equation of a straight line which passes through the point 0, minus 1 and then it is perpendicular to the line 3x minus 2y plus 5 equal to 0. Okay, now in the last one we just solved, we said that when two lines are parallel, that means they have the same gradient. Okay, but now when two lines are perpendicular, their gradient is going to give us m1 multiplied by m2 is equal to minus 1. Hello, when two lines are perpendicular, their gradient is going to give us m1 multiplied by m2 is equal to minus 1. So here, when you have your m1 already, you can solve for m2. If you have your m2 already, you can solve for m1. Okay, now let's go. We have the line 3x minus 2y plus 5 equal to 0. Okay, here let's make it properly. Let's write it properly in the equation of a line. Okay, so here we're going to take 3x to the other side and 5 to the other side. That means we're going to have minus 2y is equal to minus 3x minus 5. Divide both sides by minus 2 to make y the subject. We're going to have y is equal to 3 all over 2x plus 5 all over 2. Is that true? So here our gradient is 3 all over 2. That means our m1 is equal to 3 all over 2. So from our formula, we say that when two lines are perpendicular, m1 multiplied by m2 or m1 m2 is equal to minus 1. Here we have m1 to be 3 all over 2. So here we have 3 all over 2 m2 is equal to minus 1. So we are looking for m2. Divide both sides by 3 all over 2. So we're going to say that m2 is equal to minus 2 all over 3. So here from this line, 3x minus 2y plus 5 equal to 0, which the equation of a straight line we're going to find is perpendicular to this line. From here, we have found our gradient to be m2, which is minus 2 all over 3. All right, now let's apply our formula properly to find the equation of the straight line. So applying the formula for the equation of a straight line in slope point form, we have y minus y1 equal to m over bracket x minus x1. Okay, so and here we have our point 0 comma minus 1, and then our gradient m to be minus 2 all over 3. Okay, yes, now let's fix in our values. We're going to have y minus, our y1 is minus 1, so we have minus 1 equal to our m minus 2 all over 3 open bracket x minus our x1 is 0, so we have x minus 0 is x. So x multiplied by minus 2 all over 3 is going to give us minus 2 all over 3x. So here we have y minus 1. So y minus 1 is going to give us y plus 1. So y plus 1 is equal to minus 2 all over 3x. Let's take plus 1 to the other side. We're going to have y is equal to minus 2 all over 3x minus 1. So the equation of the straight line which passes through the point 0 and minus 1, and also that is perpendicular to the line 3x minus 2y plus 5. So the equation of the straight line is giving us y is equal to minus 2 all over 3x minus 1. All right, yes, now let's go. Let's take another special form of equation of a straight line. Another special form of equation of a straight line is 2-point form. 2-point form. So in this 2-point form, we are going to see that our gradient is equal to m, which is equal to y2 minus y1 all over x2 minus x1. All right, yes. And then you know that in our previous formula, we said that y minus y1 is equal to m open bracket x minus x1. Is that true? Yes. So in this case now we have that our m is y2 minus y1 all over x2 minus x1. So let's replace it here. We're going to say that the formula for the equation of a straight line in 2-point form is going to give us y minus y1 equal to y2 minus y1 all over x2 minus x1 open bracket x minus x1. Okay, yes, let's go. Let's take examples. Let's consider this question. Write down the equation of a straight line passing through the points minus 2 comma minus 1 and 3 comma 4. Okay, so solution here. Now we have equation of a straight line passing through 2 points. 2 points are given to us. So how can we do it? So we're going to say let x1 comma y1 be the first point, which is minus 2 comma minus 1, and then x2 comma y2 to be the second point, which is 3 comma 4. All right, let's go. Our formula, how we're going to find our m? We say that m is going to give us y2 minus y1 all over x2 minus x1. So what is our y2? y2 is equal to 4. 4 minus our y1. y1 is minus 1. So here we're going to say 4 minus 1 all over our x2. Our x2 is 3 minus our x1 minus 2. So here we're going to have 3 minus 2. So in our numerator we have 4 minus 1 going to give us 4 plus 1 all over 3 minus 2 going to give us 3 plus 2, which is equal to 4 plus 1 is equal to 5 all over 3 plus 2 is equal to 5. So 5 divided by 5 is equal to 1. So our m, the gradient here, is equal to 1. Now let's go. In our formula we have y minus y1 is equal to y2 minus y1 all over x2 minus x1 open bracket x minus x1. So here we have solved for y2 minus y1 all over x2 minus x1, and we obtain the value to be what? 1. Let's replace it. Here we're going to say that y minus y1 is minus 1 close bracket is equal to 1 open bracket x minus x1. So in place of x, I'm going to replace it with minus 2 close the bracket. Okay, so here we have y minus 1 is going to give us plus 1 equal to 1 open bracket, x minus minus 2 is going to give us plus 2. Okay, so here we have y plus 1 is equal to x plus 2. So let's take plus 1 to the other side. That means we're going to have y is equal to x plus 2 minus 1. So 2 minus 1 is equal to 1. So the equation of the straight line which passes through 2 points, minus 2 comma minus 1 and the 3 comma 4, is giving us y is equal to x plus 1. All right, yes. Now let's go. The last example, we have write the equation of a straight line passing through the point 6 comma 3 and 5 comma 8. Also show that these 2 points are equidistant from the point minus 2 comma 4. All right, yes, you say write down the equation of a straight line passing through the point 6 comma 4 and the point 5 comma 8, and also show that these 2 points are equidistant from the point minus 2 comma 4. All right, let's go. Solution. We're going to say let x1 comma y1 equal to the first point, which is 6 comma 3, and then x2 comma y2 to be the second point, which is 5 comma 8. All right, now we have our m is equal to y2 minus y1 all over x2 minus x1. So here our y2 is equal to 8 minus our y1 is equal to 3. So have all over our x2 is equal to 5 and then x1 is equal to 6. So here we have 8 minus 3 is equal to 5 and then 5 minus 6 is equal to minus 1. So here we have 5 all over minus 1, which is equal to minus 5. So our n is equal to minus 5. So probably the formula for 2-point form is y minus y1 is equal to y2 minus y1 all over x2 minus x1, open bracket, x minus x1. Okay, now let's go. Here, let's plug in our values. We have y minus y1. Our y1 is equal to 3. So we have y minus 3 is equal to, we are solved for y2 minus y1 all over x2 minus x1. Okay, and then the answer is minus 5. So we have minus 5, open bracket, x minus x1 is 6. We have minus 6. All right, let's go. We have y minus 3 is equal to, let's use this minus 5 to open the bracket. We're going to have minus 5 times x is going to give us minus 5x. And then minus 5 times minus 6 is going to give us plus 30. So here we have y minus 3 is equal to minus 5x plus 30. So let's take minus 3 to the other side. We're going to have y is equal to minus 5x plus 30 plus 3. So 30 plus 3 is equal to 33. So we are going to say that the equation of the straight line which passes through 2 points which are 6 comma 3 and the point 5 comma 8. The equation of the straight line is y is equal to minus 5x plus 33. All right, yes. Now the second form of the equation says we are to show that these 2 points are equidistant from the point minus 2 and 4. All right, now here we are to show that the point 6 comma 3 and the point 5 comma 8 are equidistant from minus 2 comma 4. What does it mean? It means that the distance from the point minus 2 comma 4 to the first point 6 comma 3 is equal to the distance from minus 2 comma 4 to the second point. Hello. So this equidistance, we have 2 points, 6 comma 3 and then 5 comma 8. We are to show that these 2 points are equidistant from a particular point. That means that the distance from the first point to the point minus 2 comma 4 is equal to the distance from the second point to the point minus 2 comma 4. All right, here now let's solve it and show for it. Okay, now let's go, let's prove for it. Now we're going to pick the 2 points together. Okay, we're going to pick from the first point to the main point that we are asked to solve. Now let's go. We're going to say let x1 comma y1, let it be a point minus 2 comma 4, and then x2 comma y2 to be the point 6 comma 3. So we say the distance from the point minus 2 comma 4 to the point 6 comma 3, which is the first point. Okay, so for us to see the distance, we're going to use the distance formula. For us to get the distance, we're going to use the what? The distance formula. What does the distance formula say? The distance formula say that instead of going to have r is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. Hello, the distance formula say that r is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so here we have fixed the value for x1, x2, y1, y2. Okay, so from the values we have minus 2 to be our x1, and then 6 to be our x2, and then we have 4 to be our y1, and then 3 to be our y2. Let's fix it in this distance formula. We're going to have square root of 6, which is our x2, minus open bracket minus 2, which is our x1, all in bracket squared, plus our y2. Our y2 we have 3 minus our y1 is equal to 4. We have 3 minus 4, all in bracket squared. Okay, so here we have 6 minus 2. We're going to give us 6 plus 2, which is equal to 8. Okay, all squared, plus 3 minus 4, all squared. So when we say 6 plus 2, it's going to give us 8. So we have 8 squared. And then 3 minus 4 is going to give us minus 1. So minus 1 squared. So 8 squared is equal to 64. Then minus 1 squared is equal to 1. So 64 plus 1 is equal to 65. So here we have square root of 65. So the distance from 6 comma 3 to the point minus 2 comma 4 is square root of 65. Now let's also find the distance from the point 5 comma 8 to the point minus 2 comma 4. Okay, now let's go. We're going to say let x1 comma y1, let it be the point minus 2 comma 4, and then x2 comma y2 to be the point 5 comma 8. Okay, now let's go. The distance from the point minus 2 comma 4 to the point 5 comma 8, we're going to use the distance formula. So the distance formula says square root of x2 minus x1 all in bracket squared plus y2 minus y1 all in bracket squared. So here we can see our x1, x2, y1, y2 clearly. All right, now let's fix them here. We're going to have x2, our x2 is 5. So we're going to have 5 minus open bracket minus 2, which is our x1, then all in bracket square, plus our y2, which is 8, minus our y1, which is 4. So here we have 4 minus 8, all in bracket squared. So here we have 5 minus minus 2 is going to give us 5 plus 2, all in bracket squared, plus 8 minus 4, all in bracket squared. So when we say 5 plus 2 is equal to 7 squared, plus 8 minus 4 is equal to 4 squared. It's still in square root. Okay, so we have square root of 7 squared plus 4 squared. So 7 squared is equal to 49 plus 4 squared is equal to 16. So 49 plus 16 is equal to square root of 65. So the point 6 comma 3 and 5 comma 8 are equidistant from the point minus 2 comma 4. Hello, that is to say the distance from the point 6 comma 3 to the point minus 2 comma 4 is equal to the distance from the point 5 comma 8 to the point minus 2 comma 4. All right, that is to say that the 2 points 6 comma 3 and 5 comma 8 are equidistant. All right, yes, now let's go. Let's take another special form of equation of a straight line. Another special form of equation of a straight line. So which form? We say intercept form. Intercept form. So this intercept form, we're going to make use of the formula x all over a plus y all over b is equal to 1. Hello. X all over a plus y all over b is equal to 1. Let's take a look at this question. Write down the equation of a straight line which intercept the axis at the point -5, 0 and 0, -4. Also find the gradient. Okay, so now let's go. That means here we have x all over a plus y all over b equal to 1. So we say that at x-intercept we have that y is equal to 0, and then at y-intercept x is equal to 0. Hello. At x-intercept y is equal to 0. At y-intercept x is equal to 0. Now here we say x-intercept we have -5, 0, and then y-intercept we have 0, -4. So here we have our a to be -5, and then our b to be -4. Okay, so here let's fix in our value. We have x all over a, and then our a is -5 plus y all over b, our b is -4, equal to 1. So let's combine this together. So the LCM of -5 and -4 is going to give us 20. So 20 divided by -5 is going to give us -4. So -4 times x is -4x, plus we have 20 divided by -4 is going to give us -5. So -5 times y is going to have -5y equal to 1. Here we have -4x plus -5y is going to give us -5y all over 20 is equal to 1. So here let's cross multiply. When we cross multiply, we're going to have that -4x minus 5y is equal to 20. Okay, -4x minus 5y is equal to 20. Let's take -4x to the other side. We're going to have -5y is equal to 20 plus 4x. Let's divide through by -5. So we're going to have that -5y divided by -5 is equal to 20 plus 4x divided by -5. Here we're going to have y is equal to 4x divided by -5 plus 20 divided by -5. Okay, so here we're going to have y is equal to -4 all over 5x plus 20 divided by -5 is equal to -4. So the equation of the straight line having the intercept at x-intercept -5, 0 and y-intercept 0, -4. Here we have y is equal to -4 all over 5x -4. So here we say that we are to find the gradient. So the gradient, we have our original formula for the equation of a straight line, y is equal to mx plus c. Okay, so here we say that our m is the gradient. So from the equation that we just obtained, we say that y is equal to -4 all over 5x. So -4 all over 5 is our m, which is the what? The gradient. All right. Yes. Thank you very much. We have treated many things about the equation of a straight line. Please, I want you to watch this video gradually, step by step, for you to understand every bit. All right. Yes. Thank you very much for watching. See you other time.